2.2, 21. So we want to find the vertex and the axis of symmetry. Now to find the vertex and the axis of symmetry, it would be good to identify the values of A, B, and C. Now B and C, A, B, and C really for the most part can be any number. A cannot be 0. That's just going to be, A is not going to be 0. And the reason I say that is because if A is indeed 0, we don't have an x squared term, which automatically does not make it a quadratic. The fact that it has x squared is why it's a quadratic function. So without x squared, it's not a quadratic anymore. So for these here, these quadratics, A is going to have a number other than 0. Does that make sense? B and C can be 0. If we don't have an x term, B is 0. If we don't have a number without a variable, it's understood to be 0. Those can be 0. Here, A is 1. B is 2 and C is 1. The vertex and our axis of symmetry. So far, the ones that I've graded, y'all have all had x equals. We had our equation for the axis of symmetry. There was a few that forgot to put that on there. And again, at this point, homework, I don't grade too heavily on. Because if most of them you'll seen, I've returned assignments, they've had stuff corrected. Unless you're missing at least half of the problem, that's when I'll start taking about a half off. Or if you did the same thing across the whole thing, then I'll do quarters. But if you notice, even if I do quarters, eighths, they will add up to be a half or a whole. I don't like leaving it as 0.25, 0.3. No, it's either going to be a half or a whole, especially at the end. So just missing that, I will rewrite it in. But if you miss the x equals the number and then one number on the vertex, that's a half. You miss the whole thing, that's a whole. Does that kind of make sense? If you do have a question on something, please ask. Now, vertex. The x value is negative b over 2a. So negative b, so negative 2 over 2 times 1. Now again, at this point, we can type that whole thing exactly as it is in the calculator, let it do it for us. If we do it by hand, the top, negative 2 is, well, just negative 2. 2 times 1 is 2. Negative 2 divided by 2 is negative 1. So the vertex, the x value of the vertex is negative 1. The axis of symmetry, x is equal to negative 1. At this point, we're going to plug it back in. Negative 1 squared plus 2 times negative 1 plus 1. When you plug this in, especially a negative, something being squared, you need to make sure you put parentheses around it. Because negative 1 squared, negative 1 times negative 1 is positive 1. Yes? If you don't put those parentheses around it and just type negative 1 squared, it will tell you it's negative 1, not positive 1. Because the calculator does not see that as negative 1 squared. It sees it as negative 1 squared. It sees it as that negative and the 1 not connected. What it's really thinking you're asking is negative, parentheses 1 squared. It's squaring the 1 and then attaching the negative to it. It sees it as two separate terms. So for us to actually have this, we need that negative inside parentheses. So it's knowing that the negative and 1 are together. We're multiplying negative 1 times itself, not 1 times itself, and applying a negative to it. The best thing I can say is when in doubt, put them. When in doubt, put the parentheses. Because if they're needed and you don't have them, it's going to hurt you. If they're not needed and you have them, it's not going to make a difference. Because here it'd be 1. 2 times negative 1 is negative 2 plus 1, which tells us the y value is 0. Questions on this here? Did that answer your question for that? Any other questions over the homework? I believe this is where we got to yesterday, yes? So, y equals, yep. So I'm just rewriting these down. So I have them here. We do have them written on the board. And there's a reason I've listed the focus in the, right underneath the vertex. Now you don't have to order this way. I'm just ordering it this way for the sake of the lesson. And the only other thing that we had is that A is equal to 1 over 4P, and P is equal to 1 over 4A. And we went over this yesterday, and I think for the most part we got a handle of this here. Because really all of this is revolving around finding the values of H, K, well, A and P. Because if we have those, I can find the equation. And if we have those values, I can find the vertex, focus, directrix, and axis of symmetry. We just need to find the values of these here. And the biggest thing is lining it up with what we have and the given information. Now this one here, vertex, 5, -1, directrix. On your paper, it does have y equals 2. Every year, even though it's been 24 hours, I forget to go back and put the y equals on this. Because again, it is y equals for the directrix, yes? Now this is the first one we had that does not have a graph. So now we need to be able to figure out which one of the two it is. Now if it gives you the directrix or axis of symmetry, it is nice because of one main thing. Let's go back to the general forms here, and that's why I listed them out. If you look at the two directrix, they're both an equation. Directrix and axis of symmetry are equations. For x equals equation, the one on the right, if we look down at the directrix is x equals h minus p, yes? It specifically has what? X equals. Our other directrix is an equation also, but it has y equals k minus p. H minus p, k minus p is just going to be a number, but both of them start off as either x equals or y equals, yes? So let's look what it told us here. Directrix is y equals. Only one of the two general forms has an equation for the directrix as y equals. And if we look at the general form, the one that has a directrix of y equals a number is our y equals. Do we see how that worked out? So that's nice with directrix and axis symmetry. It just tells us we look which one has x equals, which one has y equals. Here, y equals a times x minus h squared plus k. You can come up with a mnemonic or some way to memorize that? No. I would just keep referring back to the general form. There's no reason to need to memorize this. Keep referring back to those from one to the other. Because that y equals, all we've done so far is which one of the two are we looking at? Yes. Yes. Our x equals equation or y equals. Here, because the directrix told us it was y equals a number, we're using the y equals form. Does that make sense so far? Okay. So it told us the vertex and the directrix. In the general form, the vertex is the point h comma k. Our directrix is the equation y equals k minus p. Again, with all this here, I'm going back to the general form each and every time so we can see how everything lines up. Now for us here, they told us the vertex is 5, -1. Our directrix is y is equal to -27, halves. Again, to find our equation, we need A, H, K. I have these three. I have the equation. Now, since they gave us the vertex, it gives us H and K. H is 5, and K is our -1. So in the whole equation, y equals, we don't have A, x minus h, x minus 5 squared, plus k plus -1. Do we normally write it as plus -1? Well, no, we just say what? -1, -1. We don't. Okay. We could write it underneath, or we can just say -1. There's no reason to do that. That's also the same as saying minus a -5. We wouldn't say minus a negative, we just write plus. So at this point, what's the only thing we're missing? A, yes? To find A, we need to find P. I do a spot where P is located, yes? In our directrix. Directrix is y equals K minus P. In our K minus P, what is taking the place of it in the equation? The -27 over 2, because that is what's matching up. Because when we take our value of K, which in this case is -1, and we subtract whatever P is from it, we should get -27 over 2. Because K minus P is our directrix, and it's told from us in the equation that it's -27 over 2. Questions on this so far? Now we need to find the value P. So what can we do first? Add 1 to both sides. Yes. So now we need to add 1 to -27/2. You do not have to do this by hand. Calculator will do it for you, -25/2. And then we can divide both sides by -1. The alternative is to multiply both sides by -1. Both will work. Multiplying by 1, dividing by 1. Doesn't change the number. We're really wanting to just change the sign from positive to negative or negative to positive because we want P to be positive. Questions on how we found the value of P? Well, to find A, the number we're plugging in, 1 over 4 times our P value. Again, take that, throw it in the calculator. Let the calculator do that for you. Which is 1 over 50. So our equation for this here is y is equal to 1 over 50 times x minus 5 squared minus 1. That's it. Questions on this here? Questions on anything we've done so far? We ready for the next one? All right. I don't know why it keeps doing that. For some reason, it's not wanting to start at the top. Write an equation of a parabola with vertex -1, 4 and focus -1, 2. Now again, they didn't give us an equation or a graph to be able to look at. I think it's just vertex and focus. Yeah. I have a little bit more there. But it is the top, that one right there. Vertex -1, 4, focus -1, 2, yes? Turn the page. There. Yep. Okay. Didn't give us a graph, because the graph would have been nice, because if it opens up and down, it's y equals. If it opens left to right, it's x equals, yes? So here they gave us the vertex and focus. Now looking from one, the vertex to the focus, which of the two value changes and which one doesn't? The y value changes, yes? It goes from 4 to 2. The x value is still the same, yes? So the x value, the first value doesn't change, but the second value, the y value, does. Now if we look back at the general forms from vertex to focus, and this is why I ordered them this way. If we look at the first one, let's get a highlighter. First spot in the vertex is h, because it's still h comma k, yes? If I look at the focus's first spot, it is still just h. We didn't do anything to it. If we look at the second value of the vertex, it is k. The focus is k plus p. So most likely, p is causing a change. It's not going to guarantee that it goes up, because p could be negative, it's going to cause it to go down. It could go up or down. But for this here, if the second value changes, k to k plus p, we know it's y equals. If we look at the other general form, vertex is h, and it goes to h plus p. If the first value is changing, doesn't matter if it's increasing or decreasing. If those two values are not the same, then it's x equals. If the y value, the second value, is different, it's x equals. And we're just, again, we're comparing it back to the general form. Which one are we adding p to in the focus? Is it the first spot or the second? So if we look at this here, we see that the p value, the value of y, is going from 4 to 2. There is a change there. And since there is a change in the y value, it means it's x equals a times y minus k squared plus h. Because in the general form, for this here, our vertex is the point h comma k. Our focus is the point h comma k plus p. And the reason we knew that we're going to use this is because our vertex, -1, 4, is now -1, 2. And again, the vertex is always going to be the point h comma k. So from the vertex, h is -1, k is 4. Those are set. And if we look at the focus, h comma k plus p, is the focus still confirming, especially with the first part, h by itself, that h is still -1? Yeah. K plus p, since we're adding something to it, p's value to our k, it's causing it to change from 4 to 2. And again, to find p, we take k plus p and set it equal to 2. And what's our value of k? Well, 4. 4 plus p is 2. To find p, we would minus 4 from both sides, telling us p is -2. But we really don't need, we need p in order to find a, what we plug into our formula. And if we plug p into 1 over 4p, we get 1 over 4 times negative 2. And 1 over 4 times negative 2 is negative 1/8. So x equals our a value, negative 1/8, times y minus k, what k in this case is 4 squared plus negative 1, or we can just say minus 1. Questions on this here? Questions on anything we've done so far? We're ready for the next one. Vertex and directrix, would we have the x equals or y equals? The y equals. And it's mainly from the directrix, because between the two directrix is either x equals h minus p or y equals k minus p. Well, our y equals k minus p corresponds to our y equals a times x minus h squared plus k. And we need a, h, and k. Do we know what the value of h and k are? 8 and 9. Because our vertex corresponds to our h, comma, k. And directrix for us is corresponding to our y is equal to k minus p. So for us here, k minus p is equal to 73 over 8. And our value of k, as we said, is 9. Now to solve this here, to solve for p, and we needed to find a, we would subtract 9 from both sides, telling us negative p is equal to, well, 73 over 8 minus 9 is 1/8. So negative p is equal to 1/8. At this point, we'll divide by negative 1, telling us p is negative 1/8. So negative 1. So we need to make p positive. So we're multiplying by a number because we need to multiply both sides or divide both sides by a negative number. And 1 is chosen because it doesn't change anything. Because our negative p divided by negative 1 here. The negative divided by negative is positive. Well, p divided by 1 is p. It doesn't change it. So this is the main way we can multiply or divide to get that sign change. Yes. Any other questions? Now that we have p to find the number that goes into the equation, we need to find a. Well, a is 1 over 4p. 1 over 4 times negative 1/8. And again, I'll let the calculator do the calculating for us, telling us that a is negative 2. Now this is one of the first times a came out to be a non-fractional number. That's fine. A can be whatever it wants. It's just up to this point they've mainly been fractional. So y is equal to negative 2 times x minus h squared plus k. Questions on this here? You're starting to feel a little more comfortable with this. Because once we get the pattern and the process of how finding A, P, H, and K works, it's not too bad. Because again, we keep referring back to these general forms to find these values. We're ready for the next one. Vertex and focus. So here, does the first value or the second value change? The first one, we're going from -8 to -31/4. And if we look at the general forms, when the first value changes, we're looking at x equals. So x equals a times y minus k squared plus h. And again, we need to find the values of a, h, and k. When we plug it in, yes. So h and k being flipped, since x equals, k is on the inside, h is on the outside. But the interesting with the vertex, it's still the point h comma k. So how we plug it into the equation changes, but not so much with the vertex. Oh, are you talking about just listing them? Yeah. Now, that's a good point. If it helps for you putting them in or plugging them in to put KH, do that. Because if that helps you keep them straight, which one's going inside the parentheses, which one's staying out, do that. Because here, our K value is what? And H is... Focus is H plus P, comma, K. And this does correspond with our vertex, the fact that K is still just -9. And it does mean for us here that H plus P is -31/4. Or -8 plus P is questions on this so far? So we need to get P by itself. So what can we do to get P by itself? We can, well, add 8 to both sides, because -8 plus 8 would be 0. P is equal to, so -31/4, -31/4 plus 8 is 1/4. Questions on this here before we find A? So to find A, we're just going to plug 1/4 into our 1/4P. This here we can say 1/4 times 1/4, which turns out to be 1. Questions on AHK? Well, really AHPK. X equals. Since A is 1, do we have to list it? No, the multiplication one we don't have to list, so we can just move into our parentheses y minus k minus 9. Minus a negative, we can just put it as plus. plus h plus negative 8, which we can just write as minus 8. So for this here, the equation is x is equal to y plus 9 squared minus 8. And that is it. Questions on this here? They would not be wrong. Because you could also leave it as y minus negative 9. That's fine. That's still correct. We just don't normally write it that way. But it is correct. Questions on this here? Okay. One of these is not going to show up on the homework, but I'm going to work one of these through with y'all. Because this is the first one that we've had that did not give us what? One key piece of information. Because what did they give us? The focus and the... What did all the other ones give us? Which is the vertex. Because this is the first one that has not given us the vertex. Which isn't terrible, but the vertex always gave us HK. It always gave us that. The only thing we're having to find was P, yes? Here we're still going to have to find P. And the directrix x equals does tell us the equation x equals a times y minus k squared plus h. We are still having to find a, h, comma, and k. Now, because of the general form, focus x equals our h plus p, comma, k. For us, we have negative 63 eighths, comma, negative 7. Directrix. General form x is equal to h minus p. And for us here, x is equal to negative 65 eighths. So just in the general form, do we have any of the variables given to us? Okay. K is the only one directly given to us. Now the focus tells us that h plus p is negative 63 eighths. The directrix tells us that h minus p is negative 65 eighths. We have a system. We have a system of equations that we have to solve. Now, unlike the three variable systems of equations, we don't have three variables. But the other nice thing, even though it is two variables, in one equation p is positive and the other p is negative. So that is nice. Also, unlike any other systems of equations where the numbers in front of x and y could change, be anything we want because it's two equations, here we are dealing with a formula. These are set, h plus p, h minus p, k plus p, k minus p. They are set to those, which is nice because we can take these two as they are and put them over the top of each other. So that is one of the nice things when giving the directrix. Yes. Okay. Thank you. I have done that before where I forgot to start it back up and got all the way down. So thank you. Sometimes forgotten to turn the headset. Now, we kind of understand how we got to this here, yes? Now, with elimination, we set them up, and then we had to either add or subtract, yes? If we add these two together, if we looked at p plus negative p would be 0. It would cancel out, and we would find h. Say we didn't want to add. If we subtracted, well, the p and p would not cancel out. What's h minus h? 0. So does it matter which one we do? No, because we can find one, then we can use that to find the other. So do y'all want to add or subtract? Add. So if we add these together, h plus h is 2h. P plus negative p is 0, because we wanted one of these to cancel, either h or p. Now we have to add negative 63/8 and negative 65/8. Negative 63/8 plus negative 65/8. And if we're really lucky, it comes out to be a nice number, negative 16. So that tells us h is negative 16. At this point here, we can divide by 2, telling us h is negative 8. Now we just need to find p, yes? I have two equations. We have that h plus p is equal to negative 63/8, and we have h minus p is equal to negative 65/8. Personally, I would use this one here for one reason and one reason only. There's less steps. P is positive. I don't have to adjust for p being negative. So I can say negative 8 plus p is equal to negative 63/8. Here we would add 8 to both sides. Is 1/8. Almost done. We just need to find a. So to find a, we're going to put 1 over 4 times 1/8. Which is y minus k. Would we say this is harder, a lot harder than what we've been doing? Not a whole lot, but it's more to keep track of, yes? So I do know we do have more time. I'm going to stop here because there are 2 more of these. We're going to do one of them. I'm doing one so that y'all see them, that you know how to do them. But again, they're not going to show up on the homework. So the homework is a worksheet. Now, I'm going to go on and give you the worksheet so that you can start working on it. 1 through 4 we have not done yet. If you want to give them a shot, you can. It's essentially just going, this time they gave us the equation. That's the last set that we have in the notes that we'll do tomorrow, is we're going to go from the equation, we're going to start here and go back to the vertex, focus, directrix, and axis of symmetry. We're going to get the information. We're just going to break it down. We're going to go the other way. And to go the other way, we need P, H, and K. So there's not a whole lot more to it. But the first 4 on the homework are asking you to find and identify those pieces. The second half of the homework, and you can pass most of those back. I gave you one more. Yep. Is, given the information, find the equation. So if you want to start on those, you can. That way you can start chipping away at this assignment. because 5 through 8, find the equation, and all 5 of those, 4 of those, you are given the vertex. Either vertex in focus or vertex in directrix.